Today, we're going to merge optimality theory and some sentence processing results with coordination. So this is from Hoeks and Hendricks, 2015. And the general and interesting idea of this paper is that they can account for preferences in what you conjoin with after a TP based on semantic and pragmatic constraints rather than just syntactic constraints. So optimality theory and syntax is not limited to just syntactic constraints. You can use information like thematic roles and discourse processing effects as well. So Hoeks and Hendricks are going to take these two ideas, optimality theory and semantic constraints, discourse constraints, in order to account for the processing of coordination. So there's a general assumption that the structure of X and Y is a little bit different than other structures in syntax. So usually we do a ternary branching analysis of this, where two XPs join to make a bigger XP. Now, there are cases in syntax where this just becomes a conjunction phrase, and we can do a binary branching structure on this, but the arguments for constituency might not be convincing to everybody. So the typical ternary branching structure, which we saw in CCG as well, just cannot be accounted for in modern day X-bar theory. So what's also interesting about the coordination structure is that this is the only structure in syntax where you take two of the same phrase type and you make a bigger one. Typically, you're introducing different types of phrases as specifiers and complements, and then the head would be a specific category. So it's a little bit different. And conjunctions also don't need complete phrases to coordinate. So in the case of on or under the bridge, you're essentially doing either a P with a PP or a P bar with a prepositional phrase. So it could be the case for on or under the bridge that you actually have ellipsis here on the bridge. So you just have a PP where a couple of the words are deleted. However, you'd have to argue for that, and there'd be some additional things going on that would make the analysis a little bit more complicated. So optimality theory doesn't need to treat coordination as anything special, while other syntactic theories might have to do that. So here's some psycholinguistic background on coordination. When you start a sentence like Joe kissed Anne, and then you cut things off there, readers tend to prefer a noun phrase following and rather than a tense phrase. So if someone reads the sentence Joe kissed Anne and Mary today, there will be less of a processing delay than if you say Joe kissed Anne and Mary laughed. Now, my prosody is going to change things a little bit because I'm adding some predictability as to what comes next, but if you were to just read this on a page, the NP would be preferred over the TP. So the idea is when you get to the word laughed, there is a processing delay because that's not what you expect. You would expect some modifying word like today, which is talking about when the kissing occurred. So we can slightly reduce these effects using a comma. So the model embraced the designer and the photographer opened a bottle of expensive champagne. In the first case, after the and, it could be the model embraced the designer and the artist, right? But in the second one, if you put a comma after the designer and you see the word and, well, when we have two noun phrases back to back, we don't use a comma and. So this would tell us that we actually have a new tense phrase coming up. So this reduces processing delays. Now, Hoeks et al. In 2002 points out that actually, even with a comma, this sentence is still somewhat ambiguous. So the model embraced the designer and blah, blah, blah. So when you ask readers to take that sentence with a comma or without a comma and continue that sentence, there's actually preferences for what people like to complete these sentences with. 86% of the time, the model embraced the designer and laughed. They prefer a verb phrase. 9% of the time, they prefer an NP, so the model embraced the designer and the artist. And then only 5% of the time do they prefer a tense phrase. The model embraced the designer and the photographer opened champagne, as an example. So we do have a preference order where the VP is highly preferred over the NP, which is then weakly preferred over the tense phrase. Now, this VP preference can be ruled out as soon as you see a noun. So If you say the model embraced the designer and the artist, then we have that NP over TP preference, and we know at that point that we're not going to have a VP there. So we can actually deal with a VP-NP preference over TP using two constraints related to discourse. One constraint is called the unique topic constraint, and this says there exactly one discourse entity, which is the topic of that sentence. So what this means is if you have a noun phrase 1 and verb phrase 1 in one conjunct, and then you do an and, as soon as you introduce NP number 2, this is then a violation because you're basically introducing another discourse entity that is the topic. So you can think of it like, in a very simplified sense, it's like it prefers having one agent over two agents. Now, that's not going to help distinguish between VP and NP preference. It's just going to prevent really a tense phrase because basically you would have to have a second verb phrase in the conjunct in order to really tell that this is a new subject, it's a new discourse entity. Now, the second constraint, which is called forward discourse, is a constraint that promotes a verb phrase over a noun phrase. So this says introduce new events into the discourse. So this means that if you have NP1 and VP1 and then include an and afterwards for conjunction, basically introducing a second verb phrase is a good thing because we want to introduce new events, and new events would be verbs in this case. So if we do a tableau and we give an input sentence, the model embraced the designer and ... and we want to see what is filled, it doesn't really matter which order we have these constraints in for this case. But by introducing a TP, we have a violation in unique topic. So we're not going to consider A here. It's a violation in unique topic because we'd be introducing another subject in our sentence. And forward discourse would give a violation on the NP case because we want to introduce new events. So if we just coordinate it with another noun phrase, we're not introducing an event. So the optimal choice is to produce a VP, which is exactly what we want because this is what 86% of the time people do. So the preference in processing is the one that occurs most often. Now, let's say we have an input, the model embraced the designer and the photographer, ... and now we have to complete it. Well, we have an NP that's introduced. So in terms of the hierarchy, we have a preference of VP over NP over TP. Once we introduce the noun phrase, it can't be a verb phrase anymore. So we want to somehow get this NP preference once an NP is already in. In other words, it wants to stop after the NP, maybe include some modifiers, but it doesn't want to become a full TP. So we can use stay for that. Now, stay basically says do not move, but another way of saying it would be stay faithful to canonical word order. So what this means is that English is an SVO language. So if we do SVO and, what we want is SVO as well. So in the case of this tableau, we're going to rank stay a little bit higher than the other ones. This is a syntactic constraint. We'll say it's very strong in this case. So what stay is going to do is stay is going to have a violation in the VP. Now, why is this? Well, it's because we're doing NP1, VP1, and we're introduced to an NP2. So if we're just saying that actually it's supposed to be a verb phrase, we're supposed to have a VP instead, well, that's violating canonical word order because we should have a noun phrase, then a verb phrase, and not just a verb phrase starting. So stay is going to eliminate the VP option. Now, this is only going to occur when we have the NP, the second NP actually in there. If there was no second NP, we wouldn't get a violation because we're not breaking that word order yet. Now, in the case of unique topic, which we're ranking higher now, so we need to have this higher than forward discourse for the sake of getting the correct output. Unique topic is doing the same thing as it does before. It's going to violate a constraint for the TP because essentially, at this point, we don't want to be introducing multiple new topics. If it was just a noun phrase, then it could be another object, so it's not the focus of the new discourse entity. So that would leave us with a noun phrase as the pick. So maybe we would finish the sentence with a word like today. So even though this is only 9% of the time, we're still getting that preference once an NP has been introduced. Now, finally, If our input includes an entire TP, so the model embraced the designer and the photographer laughed, well, what do we want as our output? We want the TP to be an optimal output. We don't want to be like removing words from this case to change it to a VP or NP. So stay is going to cause violations in both the VP and NP case because we're basically saying it's and SVO. So in terms of the VP case, we obviously have a different word order because it'd be and V. So that's going to be a violation. It's not SVO. And in the case of NP, we're going to say and N, but we're not going to have a verb after it. So that is going to break up the canonical word order. And thus, these two options are going to be ruled out, and the TP will be selected. So depending on what our input is, we're able to get the correct output. Basically, if there's nothing, we want a VP. If there's an NP in there, we want to pick an NP. And if the full TP is included, well, we want the full TP to be produced in speech. Now, there's a case where semantics needs to be introduced. So when you get a sentence like Jasper sanded the board and the carpenter, ... you know inherently that Jasper is not sanding the carpenter. You know in this case that you have what's essentially a new tense phrase, and the carpenter is going to have some verb after it. And that's because you know that you can sand boards. This is a theme in this case. This is totally appropriate to sand boards. It's not appropriate to sand carpenters. So if we follow the same tableau as we did before, and we give it an input, Jasper sanded the board and the carpenter, well, we have an NP in our input, so we would pick an NP as the optimal output based on the constraints before. Now, we do not want this. This is not good. We should be picking a tense phrase because the carpenter isn't something that you can sand, and that signals that it's a new tense phrase for us. So we introduce a final constraint that is thematic fit. And that is basically a thematic element must meet the requirements of the thematic role that is assigned to it. So basically, in this case, when we think about and the carpenter, in the old case, if the carpenter is the thing being sanded, it's being signed a theme, but that doesn't really fit in with the sentence. The carpenter should not be a theme in this case. So if we make this thematic fit higher in our constraints, then we can rule out an NP. So Jasper sanded the board and the carpenter. Well, the carpenter isn't something that can be sanded, so we get a violation under thematic fit, and that's going to rule out the NP as an option. And because we have an NP already in our sentence, we should be picking a TP as an optimal output. So the VP with stay will get eliminated for the previous reasons that we discussed. It's not going to be in its canonical word order. So our optimal output is a TP. Now, it doesn't matter what order thematic fit and stay come in, but it does matter what order unique topic and forward discourse are in. So we can label this as one being either thematic fit or stay in whatever order, and then we have unique topic, and then we have forward discourse. So we can write this as a hierarchy as below, where thematic fit and stay can be in any order. That's what those commas indicate. And then the double arrows introduce the hierarchy. So we were able to match psycholinguistic evidence with what people prefer to say and understand when they read these sentences by using constraints, one syntactic, two discourse, and one semantic. We didn't even need really to talk about structure other than SVO word order. So optimality theory basically allows us to account for coordination without really talking about structure that much at all, other than the notions of phrases and movement. So there are some benefits to optimality theory in terms of sentence processing studies. One basically is that optimality theory can do semantics, pragmatics, and syntax in whatever order it wants. So with other principles, especially with generative grammar, we produce a structure first, and then we can use semantic constraints or semantic rules on top of that structure in order to rule out implausible things. So for example, we would say, in terms of a verb phrase, the structure of the verb phrase comes first, and then we fit our thematic rules into these positions. So it's a syntax first approach. But as we saw with optimality theory, we can put a thematic role constraint, a semantic constraint, before a syntactic constraint. So it's just a nice way of merging a bunch of different subfields together to explain something. The second one is OT allows us to make very easy predictions. And what I mean by that is when we have a tableau like this, we're just considering different outputs. But let's say we just wanted to put something ungrammatical in there, like an adjective phrase. Well, we could still make predictions about whether it would be picked or not based on the constraints. So obviously the thematic role, I mean, it's not really relevant because adjectives don't get thematic roles, but it's definitely going to mess up the word order. And although it's not introducing a unique topic, it also violates the forward constraint or forward discourse constraint. So it would be ruled out at the stay level as well. So there'd be no preference for an adjective phrase in this case. And finally, if you take optimality theory and you merge it with other types of theories, or should I say like offshoots of optimality theory, like harmonic grammar, harmonic serialism, stochastic optimality theory, then we can change a strict hierarchy ranking into partial rankings, and that would allow us to get a probabilistic output or value for how often or how likely it is that that sentence is okay. So that might explain why people choose VPs 86% of the time, NPs 9% of the time, and I think TPs was 4% of the time. Can't remember the exact number. It's on the previous slides. But it's not like everyone is forced into the same option. There are preferences, and using models of probability with optimality theory can get you those preferences. In terms of syntactic structures and X-bar theory, it's going to be a little bit more difficult to come up with some model that is going to give us the probability of producing a certain structure. In fact, even in psycholinguistics, when talking about syntactic trees, it can be kind of messy because some of the rules for processing are really dependent on how many nodes you have in a tree. And that can change depending on what type of theory you're using in syntax. Are you using minimalism or bare phrase structure, where it's just like read? Sorry. We can do one case where it's read book, and then the head pushes itself up into the sentence. So for John reads books, let's do that one. We only have like 1, 2, 3, 4, 5 nodes, but there's another theory that we've been using where actually it'd be like a TP with T bar and T. And we have a verb phrase here with the position for the subject and object, and there's some movement that occurs. So a lot of the stuff in principles and parameters, X-bar theory, in terms of psycholinguistic effects, can be explained with tree structures, but it's sometimes a little bit odd. At least that's my opinion. So anyways, that's a nice connection between OT and human sentence processing. And you also get to see a little bit of how coordination works in optimality theory, which is something we also saw in CCG. So it's kind of nice to compare and contrast those two different types of analyses for coordination.